Hi, today we've got a multimeter review. So this turned up on my doorstep this morning courtesy of Banggood. So this is the Mustool MT826 and they're retailing this for around £40. So it seems to be similarly spec to Isotech and 10mm around this price range. So it's a typical 6000 count multimeter with all your usual functions. It also has a USB data interface, so I haven't had a look at the specifications yet, so I don't know what we can do with that, but what we'll do is we'll go down to the bench, take this out of the box and have a look at it. We'll have a look inside, and then we'll do a few tests against some of the multimeters that I've got on the bench. Right, so here we have the box, so let's have a look and see what we've got inside. So it looks like it comes in a nice pouch with the Mustool branding on the front. In the front here we've got the user manual and a little warranty card. Here we've got a adapter that looks like it's for the transistor tester and the thermocouple. We've got the multimeter itself and various leads in here. Right, so here we have the contents of the pouch. So we've got the multimeter on the right here. We've got the test leads, which are actually really nice quality. We've got silicone cables. The probes themselves are, feel quite nice. We've got the probe covers to make them GS38 compliant, but you can remove those, so you can use the full length of the probes if you like to. We've got a thermocouple with some 4mm plugs on the end. We've got a mini USB cable for connecting this to the PC. And then we've got an adapter for plugging in a K-type thermocouple with a standard connector, or plugging in our transistors for the HFE measurement. Interestingly, there's only 2 terminals on here, so I don't know quite how they're doing the HFE measurement, so maybe we'll have a look to see whether that works properly or not. But overall, the quality of this doesn't seem too bad at first glance. The holster isn't particularly rubbery, but it all feels really nicely built. It's not too bad at all. We've got the range selector switch, which is really quite clicky. It does have a tendency to skip across one if you just use a light pressure towards the end of the selector, but if you take a bit of care, it's quite easily selecting the ranges. We've got off on both ends of the range selector, so obviously if you like to use it on the amps range regularly, you don't have to go far there. But oddly, all of these have the AC symbol here, so it seems a bit odd that it's defaulting to AC measurement, unless that's a misprint. We'll see what happens when we power this up. But overall, there's nothing too bad to say about it at first glance. These buttons are nice. They've got a nice feedback here when you press them in. It doesn't seem too bad. Let's take it apart and have a look inside. So this unit takes 4 AA batteries, and the battery cover actually has some M3 screws and brass inserts here, so that's quite nice to see on a meter of this price point. We might have to take these batteries out. Oh, these these feel really light. Super heavy duty, I don't think. And that just pulls apart. That's quite interesting. We'll have a look at that in a moment. So let me zoom in. So we've got the battery holder here with 2 wires soldered on, and that actually goes to a connector for the front PCB. What I was just wondering about there is that there's this completely separate PCB for the USB interface. I can see now how that's working, so we'll have a look at that in a moment. But let's just have a look at the main PCB. So we'll start off looking towards the input section. So here we've got a couple of fuses, the 600 milliamp fuse and the 10 amp fuse. They are ceramic, but they don't look to be HRC fuses in the style that we know for some of the higher quality meters, but at least they've used some ceramic fuses rather than glass, so they won't blow up when you accidentally set it on the wrong range. We've got the 10 amp current shunt here. We've got a couple of resistors here. I'm not quite sure what these are doing down this end. For the input protection, at least on this side, the only thing that's visible is these PTCs, so there's 4 PTCs there. There may be something on the other side. We'll have a look when we take it apart a bit further, but that's really all there is towards this bottom edge. The actual banana plugs don't look too bad at all, so they've got a sleeve that goes the whole way around the 4mm port, but they are completely open, so if you did happen to drop some stuff in there, it would just end up in the cavity here. And then just looking towards the top of the PCB, we've got the battery connector on the top right here. We've got a couple of wires going off to the front of the PCB, so that must be the LCD backlight. We've got a transistor here, which appears to be connected to here, so that's obviously to turn the backlight on and off. We've got a microcontroller here, so that's a Hycon HY11P14, which is a 8-bit microcontroller with an LCD driver built in, and also an 18-bit Sigma Delta ADC. So I did think this might be the ADC down here, but this has a 18-bit one built in. We've got a crystal attached to it. This also has a crystal attached to it, and it appears to be attached to a lot of these passives, so potentially it's a true RMS converter chip, although I didn't find any details on the part number on here. This is a true RMS multimeter, so that's my only assumption here. We've got some EEPROM here, so it must do data logging functions. That's what the USB interface is for. We've got a regulator, a buzzer, a few more components around here. We've got plus and minus, so potentially on another model there's some spring terminals here instead, which connect to the pads instead of using this connector up here. And then we've got an infrared LED here, which says TX. So what did confuse me and stop me briefly when I took the cover off was just this standalone PCB for the USB interface, but clearly this is powered from the USB port, and it just has a little phototransistor or photodiode here receiving data, and it's just being streamed straight out. So this is probably just a standard serial to USB converter chip, and they're just streaming serial straight out. That does mean that either this is always firing out all of the data, or it only does it when you hold down this button and you have to sync it with the software. I don't know, I haven't had a look. I didn't actually see any CD or anything in the pack, so we'll have a look at that if we find some software for it. But that's really about all there is on this side. So this looks fairly kind of simple, and you know, this is supposedly Cat4 rated. We'll see if there's any other parts on the back of the PCB. I mean, there are some slots where it's appropriate, and we've got a reasonable depth here for blast protection. But what we'll do is we'll take the PCB out and have a look on the other side. And actually, I've just had a quick look. This is a CH3400 serial to USB converter chip. So yeah, this is really just receiving serial data from the other microcontroller and just streaming it straight out onto the USB port. Okay, we've got some loose parts here. Right, so there really is nothing on this side. We've just got the range selector. We've got the backlight for the LCD, and really that's about it. So hopefully I'll be able to get this back together. There's a little bit of dust in here, but yeah, nothing really on this side. So that really was all the input protection that existed, so just the PTCs. So what we'll do now is we'll assemble it all back together and then give it a little test. So just as I was assembling this back together, it did occur to me that obviously these two resistors here are for the milliamp and the microamp range. So this does have a microamp range, so we'll be using a higher value resistor than for the milliamp range, and then obviously we've got the big current shunt for the 10 amp range. We're looking at PCB version 1.3, and this appears to have been made in 2014. It does look like a rebranded product, so there's a couple of Chinese brands with the 8236 designation, but yeah, Banggood is selling this as their own brand. And it also looks like they've added a little bit of shielding to the back here, and there's a corresponding spring terminal here to connect to this shielding. Oddly, it's nowhere near the microcontroller or the things that might appear to be sensitive. There's not really anything going on down here, so I'm not quite sure why it's here, but obviously someone's decided it's needed, otherwise they would have not bothered including it. So I think I'll put some Energizer industrial batteries in here. In comparison, I haven't got any portable scales, but literally these 4 batteries that came with it are about the same weight as one of these industrial AA batteries, so the capacity of these is going to be tiny. They might be useful for a few clocks around the house, but I won't bother sticking them in here. You'd hope that the battery life from this thing will be quite good actually, considering it's taking 4 AA batteries. We've got some serious capacity here, so I expect, you know, kind of reasonable life from this. Right, so the moment of truth, let's see if I wrecked the Zebra connector on the LCD. No, that all looks good. Yeah, and it defaults to DC measurement on the volts range. I would guess if you press the function button we switch to AC. And back again, yeah, that seems to make sense. We've got the range switch for manual ranging. So you probably hold it to get back to auto range. Yeah, that makes sense. We've got the hold button. So that's the reading hold, and you must hold it to turn on the backlight. And that looks like a nice backlight. It's quite even, white in colour. There's a little bit of highlighting just to the left where the LEDs must be, but that's certainly not too bad, better than some of the meters that I've seen. We've got the max and minimum measurement. Oh, and the backlight turns off, looks like after about 10 seconds, so that's potentially annoying. I don't know if there's a way to keep the backlight on. We'll have to have a look in the manual. And then we've got all the other ranges. So we'll do a couple of measurements. I don't actually have a voltage reference, but I've got a voltage reference chip which I've put on a breadboard, so we'll connect that up and compare it to, let's compare it to the Fluke 87. Right, so here we have the multimeters side by side, and just bear in mind that these are just spot measurements, just to have a quick look at the general accuracy. It's not to be a definitive guide, because obviously there's drift and everything else to take into account. But I've got a reference chip on a piece of breadboard here, which has been powered up for a few minutes here. So let's have a look at how the 2 meters compare. So that's pretty good. It's a 5-volt reference, obviously. The Fluke 87 is calibrated and pretty much spot on. So that's reading 5 volts exactly. And the Mustool is reading 4.999 volts. So that's not too bad at all. So I'll just connect it up to the bench power supply and we'll sweep through some of the ranges and just have a look to see how the two compare. Right, so I've connected up the 2 meters to a TTI PL303 power supply. So we'll do a few spot checks just to see how the two readings compare. And just looking at the specifications for the Mustool, they reckon about plus or minus 0.7% plus 2 counts. So it should reasonably closely track the Fluke 87 if that specification is correct. So let's start increasing the voltage. Yeah, so we're basically 1 count out at about 1.5 volts. And again about 1 count out, possibly none, at about 2.5 volts. And at 5 volts we saw it was basically 1 count out. Let's take it into the next range. And yeah, it's fairly closely tracking it around that voltage there. And again, it's probably about 1 count out at 11.6 volts. At 17 volts, we're about 1 count out once again. And again, 1 count out at about 25 volts. And we're just starting to slip slightly here, so between 2 and 3 counts here. And that's about 4 counts out. And we're just starting to lose it here a little bit, so 5 counts towards 60 volts. So, I mean, that doesn't seem too bad, that's fairly closely tracking. Let's hook it up to the Variac and have a look how it handles AC. Right, so we've got the 2 meters hooked up to the Variac, so we'll see how the 2 meters compare on AC. There will be a little bit more variance than we would have seen on the DC range, because this is now susceptible to fluctuations on the AC supply, but we'll get an idea to see how well the 2 voltage ranges track. And for the AC voltage range, we're expecting to see about 0.8% accuracy plus 3 digits, which is obviously still a little bit worse than the Fluke 87, but it should reasonably well track. So we've got about 20 volts there, and we're seeing a few counts out again. And again, it's just the last digit that's out here. It looks to be somewhere around 6 counts out, but you can see what I mean. The voltage is fluctuating slightly just as the demand on the street changes. And we've got about 93 volts there. We're reasonably close there, just 1 count out at the end here. We've got 139 volts, and again, just a couple of counts out there. 193 volts, and yeah, just 3 or 4 counts out again. And at maximum on the variac, we're kind of about 4 counts out. So that's reasonably well tracking actually, if you take into account the accuracy of the Fluke, which is calibrated, but it's not going to be absolutely spot on at this moment in time. There probably will be a count or 2 out. That's within its specification. You can imagine that this is actually quite reasonably well performing to its specifications. So we'll have a quick look at the current ranges, and then we'll just see how things like the continuity buzzer and everything like that works. Right, so I've got the 2 meters connected in series with a 10 ohm resistor on the PL303. Unfortunately, I don't have a precision current supply, so we are going to see a little bit of fluctuation. We're going to see kind of some thermal effects of this resistor and also the power supply. But the accuracy that we're expecting to see on the DC current range is about 1.2% plus 3 digits. So we'll see how the two track anyway. There is going to be a bit of fluctuation, as you can see, but we'll get an idea for how accurate it is. So yeah, we're just reading a couple of counts out. As you can see what I mean, there's a little bit of fluctuation here. And we're about 1 count out at 77 milliamps. We can only go up to 400 on the milliamp range on the Fluke. This does have a 600 milliamp range, but we'll only take it up to 400. And again, we're about 1 count out there. And again, about 1 count out at 221 milliamps. And we may as well just go up to 400. And there we go, we're just a couple of counts out again. So that's fairly well tracking in the milliamp range. Let's move over to the 10 amp range. Right, so we've got the 2 10 amp ranges connected up in series now, so let's start increasing the current. So at 45 milliamps we're about 3 counts out. And then we're about 2 counts out at 133 milliamps. And about 3 counts out at 640 milliamps. At 1 amp we're about 4 counts out here. At 3 amps we're 5 counts out, and we'll just take it up to max. And at 6 amps we're kind of about 4 counts out, but that's fairly closely tracking between the Fluke and the Mustool. So for those spot measurements there, that's really not too bad. We'll just have a quick look at the resistance range. So I have got a pair of precision resistors. We'll see how the continuity range looks, and then I think that's the end of the video. Right, so here we have a 1K resistor, and on the Fluke 87 you can see that's clearly reading 1K exactly. So let's have a look at the Mustool. And it took a short while there to auto range, but that's also reading 1K exactly, so that's pretty good. Let's try the 10K resistor. We're not doing a 4-wire measurement obviously, and we're reading 9.99 kiloohms. So let's try that on the Fluke 87. And there we go, that's reading 10. So it's just 1 count out on the 10 kilo ohm range. And in terms of accuracy, let's have a quick look at what we're expecting on resistance. So 1.2% plus 5 counts. So that's a lot better than that, at least on this meter at this moment in time. At a different temperature, obviously we're going to see some effects there. There were no precision networks of resistors in there on ceramic substrate or anything like that. So it was using probably just standard metal film or carbon resistors with, probably 1% accuracy and a reasonable kind of temperature coefficient. So at the room temperature, which is about 22 degrees at the moment, the 2 meters seem to be fairly closely matched. So let's just have a quick look at the continuity function, just to see how the beeper works. So we've now got the probes connected to the multimeter and we've got the continuity mode selected. So let's have a look how quick it responds. Wow, so that's literally about 1 second before it registers the continuity. Yeah, that's really quite slow. If you compare that to the Fluke, let's just plug that in. So the Fluke's obviously almost instant. I think probably the only meter that I've got that's about this slow is the Meterman 37XR, which is now obviously owned by Amprobe. But that really is quite slow. You certainly wouldn't want to be probing around your circuit trying to find continuity at different points to see where things are connected up, because that is really quite slow. On the actual resistance range, I didn't quite see how slow it was at auto ranging. Yeah, so it's about 1 second to auto range on the 1K resistor. So the auto ranging is a little bit slow, but did it display any? It did display a few false readings before it got there. It'd be better if it just said overload until it had reached the range. That seems to be something which is reasonably common for this type of multimeter. But the accuracy is reasonably spot on. It's just there's a few bits and bobs here and there which aren't quite as tidy as a more expensive meter. So I'm not going to go through the rest of the functions here. I think we've got an idea for how this meter works. I'll just quickly have a look to see if I can find any software for this to do any data logging or anything like that, because nothing came in the box or in the bag. So I'll see if I can find something online for connecting it to the PC. And indeed, I'm actually mistaken. There was a CD just hidden in the sleeve in the bag. So I'll see what software is on here and load it up onto the PC. It looks like it's designed for real-time measurement, but we'll see what happens when we fire up the software. So I've tried putting the CD into the PC, and unfortunately it doesn't seem to want to read it. But I did connect it up to the USB port, and it says USB on here once you hold down the USB button. And it is streaming some data to the USB port, so you can see here. I'm not sure what the baud rate is. I estimate it's something about 1200 or 2400, considering it just has that infrared LED, a one-way link. But I can't make any sense of the numbers. I've tried the various number formats that are on Realterm, but it doesn't show anything. There seems to be at least kind of 8 numbers being updated every second, so I assume there's some kind of header information saying what range it's on and that kind of thing. So I will contact Banggood to see if they have the proper software, but it really does look like it's only for reading the current value rather than any kind of data logging. So that EEPROM chip that was on the multimeter is clearly just for calibration data. So overall, in terms of this multimeter, it was provided to me free of charge, but for £40 it seems reasonably well specified. We saw the accuracy, or well, the spot check accuracy compared to the Fluke 87, and it reasonably well tracked actually. It's really not too bad. Time will tell how the readings drift and everything like that, but in terms of how it appears to be behaving today, it's really quite usable. The only complaint that I have is the continuity mode. That buzzer just takes way too long to register the contact. But other than that, I would recommend this meter. Personally, I still prefer the more expensive meters. I prefer the brands like Fluke and Agilent and that kind of thing. But certainly if I was a hobbyist, I would be tempted by this meter. It seems to be reasonably similar to, as I said, the Isotex and that kind of thing. But yeah, £40 shipped. It seems to have a nice range of features. The USB function, possibly slightly pointless, but everything else seems to be a fairly solid performer. So if you enjoyed this video, please give a thumbs up, subscribe if you haven't already. I've got a project video coming up next, so stay tuned. It's not all going to be reviews, but thanks for watching.